So this is a report on the analysis of ozone depletion, a scientific assessment which has been going on for a while. This report extends that idea to project into the future as to what will happen if the ozone recovery will continue and the ozone depleting substances will be phased out. So some interesting results, but again, unfortunately, we rely on future projections and how they will continue to reduce ozone depleting substances. So here are the CFC 11 equivalent emissions in million tons per year. So all HFCs, halons, and CFCs, including chlorine substances, are taken into account to bring them to the same scale in terms of their impact, like we did CO2 equivalent, and looking at their future emissions reductions, so goes out to 2100. So you can see that the drop to some level is expected to happen, and then they will remain steady over time at that level in terms of millions of tons per year. And if you look at equivalent chlorine, effective equivalent chlorine in ppbs, that is expected to reach the 1980 level in the 2050s and then keep dropping out to 2100. Obviously, once you go beyond where we are in 2022, these are projections, and they use the projections we have talked about before, like the shared socioeconomic pathways 1.91, etc., which correspond to radiative imbalance, which depend on emissions, and various other choices on sustainability, mitigation, adaptation, and expected conflicts, and business as usual, and so on. Okay, bromine has a multiplication factor here because it's much higher in terms of its global warming potential and ozone depletion than the other CFCs and HFCs. So if you look at what has happened in terms of annual global total ozone over 60 south to 60 north in Dobson units, and just for the October Antarctic total ozone over 70 south to 90 south, which has been the focus of ozone hole processes and impacts. So we are looking at observations and its mean. So we dipped and we have slowly been recovering since the Montreal Protocol, Montreal Extension, Beijing Extension, Kigali Amendment, Kigali Extension, and so on, the various agreements that have been made over time. And then there are future projections with the uncertainty. So even the past has uncertainties because of local measurements and global estimates and so on and so forth. But if you look at future projection scenarios for SSP 1 to 2.6 to SSP 3 7.0, obviously this is much less in terms of human intervention of emissions and other policies and mitigation, adaptation, etc., to reduce global warming. So SSP 1 2.6 is the is the best scenario, staying below 1.5. So that'll keep us here, so still below where we started in the 1960s. And the October ozone hole in terms of Dobson units will recover almost back to back to the 1960s. So obviously this is 70 south to 90 north, and here is the 1980 level. So obviously we have to remember that these are projections and they have large uncertainties. I won't read the entire caption of these figures here, but you can follow up. But just keep in mind that the report is optimistic about how global warming will be reduced if we continue with our efforts to phase out CFCs, HFCs, and other ozone depleting substances like the feedstock that go into producing these chemicals. These are the annual emissions or production in gigagrams per year. So the reported production has dropped to zero by now, and if you look at the emissions and productions, NOAA observations, and A-gauge observations, these are the 2002 to 2012 mean, and there were projections made in 2006 and made again in 2012. So the 2006 projections obviously didn't turn out to be good in that sense. So production didn't drop as much. In fact, there was an increase annual emissions and productions in the 2010s, and one of the NOAA observations indicates that maybe we are now more realistically heading to the 2012 projections. These are the HFC emissions and again observations and scenarios. So without control measures, where we would end up if we started in 2018, what would Kigali Amendment do in terms of the emissions in gigaton CO2 equivalent per year, and if we hit zero production, where we would be, and the Kigali Amendment of 2018 would be here. Okay, so obviously Kigali Amendment was a compromise that results in an increase here in the near term, even though by the end it will reach similar amounts but still slightly higher. If we look at the impact in terms of temperature contributions, okay, these are the parallel events here. So surface temperature HFCs without Kigali, without control measures agreed upon in 2018, we would end up here. Kigali Amendment would bring us here, and Kigali Amendment 22 update would again bring us down here. So you can see that we are tightening the lid in terms of where we want to head, but zero production from 2023 on would bring us here. So the replacement of HFCs is not yet here, and developing countries like India have been given room to phase it out later in the 2030s and so on. So for comparison, the total warming from all greenhouse gases is projected to be 1.54 degrees C to 4.4 degrees C by the end of 21st century relative to 1850 to 1900. So those are the AR6 projections. So the contributions of HFC 23 emissions is not included here. So there are some details you have to look out, but my goal here is to give you a brief introduction to what is being considered in this new ozone assessment report, and why the message has been optimistic in the media about how controlling ozone and ozone hole will reduce global warming by up to half a degree or so. The observed and simulated ozone trends from 2000 to 2020 show here that averaged over 35 to 60 south, 20 south to 20 north, and 35 north to 60 north. Near surface, you have a higher ozone trend because of the fossil fuel consumption and so on. And as you go into upper latitude, the agreements between models and observations get better, and the uncertainties are large in the observations as well as the models. But you can see in the lower atmosphere, the agreement is not as great. In fact, there are disagreements in the trends between the model and the observations because of the atmospheric chemistry that's involved here in ozone production and destruction. This agreement is again similar in the 20 south, 20 north, and 35 north, 35 north to 60 north, sorry. And you can see here the divergence in the model and observations is much greater in the northern hemisphere, where there is much more human activity and so on. So there are some details you can read in the report. It's a fairly long report, and I'm just summarizing it. Stratospheric ozone change and its influence on climate. So this must be something that has to be understood. Stratospheric ozone has a wide-ranging influence on the Earth system. Antarctic ozone depletion caused an expansion of the tropics and a poleward shift of the jet stream and storm tracks in the southern hemisphere that led to pronounced changes in summertime surface climate, as summarized in the previous assessment. Continuing ozone recovery and increases in atmospheric greenhouse gas concentrations will be key drivers of future southern hemisphere climate changes. The relative importance of ozone recovery for future southern hemisphere climate will depend on the magnitude and rate of atmospheric greenhouse gas concentration changes. Okay, so you have to be careful also about column integrated values versus stratospheric values, because ozone in the troposphere is not good. Ozone in the stratosphere is good, so we have to always be aware of this. This is showing the southern hemisphere circulation changes during ozone depletion and recovery. So this is the jet position that we just mentioned, and this is the Hadley cell edge, the tropics as you would call it, changing. Okay, so the tropics had expanded and now they are recovering in that sense. The other thing is to look at the impacts of considered geoengineering experiments, which unfortunately are already occurring by a private company. Stratospheric aerosol injection and potential impacts on ozone. Global warming has now reached approximately 1.2 degrees C above pre-industrial levels. Climate model scenarios considered by IPCC indicate continued future warming in the next few decades, even with ambitious mitigation and decarbonization, leading to further climate impacts. Stratospheric aerosol injection, SAI, has the potential to limit the rise in global surface temperatures by increasing the concentrations of particles in the stratosphere. These particles reflect a fraction of sunlight back to space in a process similar to that evident after large volcanic eruptions. That's where the logic comes from. However, SAI comes with significant risks and can cause unintended consequences, which we have discussed in terms of the changes in rainfall distributions and droughts, cooling temperatures and affecting crop yields, etc. The 2022 assessment is the first to dedicate a chapter to assess the potential impacts on stratospheric ozone in possible SAI scenarios in the coming decades based on the limited number of model simulations that have been performed to date. Okay. So this is how the scenarios look like. This is just broadly time in decades, and we are coming out of the historic period, and global surface temperatures will increase in this direction with limited or no mitigation. So this is the business as usual scenarios with high-end global warming. Aggressive mitigation and CO2 removal, CDR, will bring us down here. Peak shaving, so that's SAI with aggressive mitigation and CDR. So how do we avoid these peak warmings we will hit before we turn down even when we do aggressive mitigation and CO2 removal? Well, this is what is proposed, and there are some very vocal proponents of SAI as a viable and doable and feasible, whatever word you want to use geoengineering approach. So this is the temperature offset due to SAI, and this is the assumed stabilization temperature, which can be 1.5 degrees or 2 degrees by 2100 with some 61% probability. The report also considers the impact of ozone change in alternative scenarios. I won't go into the details here, but basically it's about changing total column ozone in percentage, decreasing ozone in this direction and increasing ozone in this directions with various scenarios. Bank recapture and destruction in 2023, for example, means bank is where the ozone depleting substances have been contained in some way after production or stored and being used in a contained manner. So if we can recapture and destroy, that's one thing. You have elimination of production of HFCs and bromine compounds. Feedstocks, so feedstocks are the ingredients that go into producing them. So if feedstocks increased, you will have total column ozone decreasing, and if feedstocks are eliminated, you will recover the total column ozone by some amount in percentages and so on. So if you eliminate emissions from 23 onwards, that's what you will get. So just keep those in mind. Again, keep in mind these are column ozone, so you have to be always careful. These scenarios also come with changes in radiative forcing in alternative scenarios, and you can see that reduced forcing, decreasing climate forcing is always good, because greenhouse gases are increasing the trapped energy and increasing climate forcing. So again, feedstock increases and increased bank size of CFC11 will give us increased climate forcing, whereas the others will decrease with elimination of emissions from HFCs, high global warming potential HFCs like HFC 23 will give us a large, relatively large decrease in total radiative forcing in watts per meter squared. Okay, again, these are just the scenarios again. Peak shaving versus strong SAI. So strong SAI will go after scenarios where there is limited or no mitigation and high-end global warming. So obviously the amount of spraying of aerosols into the stratosphere will be tremendously high, as opposed to peak shaving SAIs, right? So these are aggressive mitigation and CO2 removal by policy and actions, whereas the SAI will be only used to peak shaving. And you can do medium SAI and injection of precursor aerosols for SAI scenarios and so on. Obviously these are all imaginations to some extent, because the unintended consequences are not fully quantified, neither are the global agreements that will be needed to make these kinds of efforts, protocols, norms, punishments, etc. To conclude, let's look at some points. Post-Kigali information of interest. Kigali Amendment to the Montreal Protocol, along with regional and national regulatory and voluntary actions taken before Kigali entered into force, is expected to substantially limit future climate forcing by HFCs. Elimination of all long-lived HFC emissions, including HFC 23, from 2023 onward, represents an extreme example of the potential opportunities for future SFC forcing reductions, and would reduce the average radiative forcing over 2023 to 2100 by 79 milliwatts per meter squared, with additional actions which I'm not going to read about it. If emissions of HFC 23, a potent greenhouse gas, remain at the current relative level compared to HCFC 22 production, HFC 23 has the potential to cause about half of the climate forcing, 30 milliwatt per meter squared, of all other HFCs combined by 2100. Our ability to accurately predict future changes in the ozone layer continues to be limited more by uncertainties in the future levels of CO2, CH4 and N2O than by uncertainties in the levels of ozone depleting substances. So these still remain a big uncertainty, and again the fact is scenarios begin to be dominant uncertainties beyond 2050. Okay? The influence of hydrogen as an energy carrier on stratospheric ozone remains uncertain. So hydrogen is being pushed as the big savior in terms of renewable energy, especially if we can find ways to catalyze water or electrolyze water to separate H2, green hydrogen, and so on. But this again is a technological promise that may or may not be fully realized as we keep on building future scenarios on those things, on carbon dioxide removal, carbon capture, bioenergy, and so on. So keep all those things in mind and take the optimistic message with some grain of salt, if you will. Okay.